We're going to do some basic vector addition, and these problems are can be a kind of just a list of vectors, really, right? They don't have to be big, intensive word problems. They can just be a list of vectors for us to practice with. So that's kind of what we're going to do today. I want us to think about that problem on the homework, the second to last one, where I talked about Tiger Woods did all 4 of these things before he, I don't know what it's like. He made it or he gave up. I don't know.
That one was difficult.
Okay, so that's the type of problem we're going to look at, is where we've got multiple vectors we've got to account for. And so if you asked me on that question, I told you to solve each of the vectors individually. And that's what I think our method really should be, is that instead of using the picture to, look at what the whole system looks like, it's going to be simpler to just solve each vector individually. So what we're going to do is we're just going to dive into a couple practices, and we'll get a little bit more, we'll add some vectors as we go. So let's say that someone walked 500 miles. And then 500 more. Okay. Walked 4.8 kilometers at 36 degrees east of south. Then they walked 6 kilometers at 31 degrees north of west. Right? So then we want to find out how far are they from where they started, their displacement. Okay? So I want to draw the big picture so you can get an idea of what it looks like, but it's not going to do us a whole lot of good to spend time envisioning this picture and seeing really what happened. So east of south means we went here, 36 degrees for 4.8. Then we went north of west, which means we kind of tracked this way again, right? We kind of went back in that same direction, right? If here's our new origin, we went north of west. They kind of come back this way, but maybe at a different angle, right? 31 degrees north of west, maybe we're this way a little bit. Okay, do you kind of envision what's happening? But things are still fuzzy in this triangle. It doesn't give us a clear picture of what should be happening here. But in general, we know that our final displacement should be somewhere in that region. Okay? But this picture doesn't give us a good, clear picture of what's happening. So you don't need to bother drawing it. If it were me, I would just kind of ignore this first drawing and treat our vectors as individual, right? So here's our vector 1. So I'm going to say V1 is 4.8 at 36 degrees east of south. And I'm going to go ahead and draw that vector individually. Okay, I just want to focus on that one. Okay, so we said if it's east of south, we're going to draw the vector in that direction. And then east of south means that angle needs to touch which axes? East of south means it needs to touch the south axes and then swing to the east. So 4.8. Okay, and if I was going to label sides of this resultant vector triangle, what would I label these sides as? Okay, but more specifically, this is the first vector y side. This one is the first vector x side, right? V1x and V1y. Okay, so let's go ahead and solve for those things. You'll see that I usually always solve for x first. I don't know why. It just keeps me a little bit more organized to have a pattern or a system when I'm solving these problems rather than get my x's and y's mixed up. So to solve for V1x, I would take, what do I use, sine or cosine? Opposite and hypotenuse. This one is sine. So remember how I said usually x is cosine, but not always, right? Depends on the angle. So this one is sine, 4.8 times sine of 36. And for y this time, I would use cosine. So be really careful about that. It's not a rule about x and y. It's about where they're at in that triangle. 4.8 sine 36 gives me 2.82. And 4.8 cosine of 36 gives me 3.88. Do I need to add any negatives to my components? For x, do x or y need negatives? Yeah, y needs a negative because it's going south. Remember, we're thinking about how do we get from the origin to the resultant. So I had to go down and then to the right. Okay, so there's my V1 components. Let's do V2. Second vector was 6 kilometers at 31 degrees north of west. So V2, north of west is here. 31 degrees is probably a little less than that. Okay, north of west means I want to touch the west axes. And there's my 31. 6 kilometers is my resultant. So I would call this side what? What would I name that side? V2y, good. V2y and V2x. So now I go ahead and solve for those. V2x equals, in this case for x, what would I use this time? Cosine, because it's adjacent now. So 6 times cosine of 31, 6 times sine of 31. Make sure your calculator's in degrees, not radians. So if your numbers aren't coming out like mine, it's probably because your calculator's in radians. Okay, do either of my components there need a negative? My x component needs a negative because I had to go west. Right? Here's the origin. Think about just on a graphing plane, right? Think about your coordinate system. Along the x-axis, these would be negatives, right? These would be negatives. So when we think about which ones need to be negative, think about your coordinate plane. All right, so now we're going to look at, we've broken our components into their x's and y's. And so what's the next step? Add the x's, add the y's. Okay, so now I'm going to look at my total Vx equals 2.82 plus negative 5.14. 2.82 minus 5.14 gives me negative 2.32. So that's my x component, Vx. My y component, resultant, is negative 3.88 plus 3.09. Gives me negative 0.79 for my y component. So now, using these two components, I can go build my resultant triangle. Yes? I can go build my resultant triangle. Okay, so I'm going to clear some space here on my screen, but I need to build my resultant using those two components. So I've got an x and a y that are both negative. It does not matter which direction I go first. All right, I'll go negative 2.32, then negative 0.79, which means my resultant looks like that. And I want to find the hypotenuse and the angle. Notice how in the first picture I drew, my resultant really didn't look like that. Right? So that first picture I drew was not to scale. It was not maybe with my correct angles. And so it would have thrown me off completely because it doesn't match what I drew here. This one is correct, right? Because all of our math was correct and all of that. So when we draw things without a scale, it can sometimes even skew what we're supposed to be looking for. So I hope that didn't confuse you at the beginning, but this should be what our final one looks like. So how do I go ahead and solve for that? Right, this is my final resultant vector. I need to use Pythagorean theorem in second tangent. So when you use Pythagorean theorem, we don't have to plug in the negatives here or in the tangent part of it, because the negative just tells us direction about which way to go, left and down. So don't bother plugging in the negative when we do the math here. All right, go ahead and plug that in and see what you get. And we want to report our answer as blank kilometers at so many degrees blank of blank. Okay, is that about what we had for hypotenuse and for our angle? Hypotenuse we found by using Pythagorean theorem, 2.45 kilometers at, then our 18 degrees we found by taking second tangent of opposite, 0.79, over adjacent, right? Here's my opposite, here's my adjacent side, so 0.79 divided by 2.32, that's where I got that 18.8 degree angle. And then what's my cardinal directions that go with it here? South of west. Perfect. South of west. Okay, so you've got three vectors there. 51 meters at 30 degrees north of east, 40 meters south, 10 meters at 64 degrees south of east. Okay? And then I'll write kind of the steps up here just to remind you. Bless you. So I've done step 1 and 2, break into x and y, add my x's and y's. Last step's to build my final triangle. I'll try to do that small here in the corner. My x component is positive, but my y component is negative, so I know I'm going to have to go southeast somewhere. So I'll go 45 here, or 48, sorry, 48.58. Then I need to go down 23. And that means my resultant vector looks like that. So I'm going to find that in my angle. This side is 23.48. So I'll go Pythagorean theorem.